All metals have common characteristics that make them unique. What differentiates metals from other substances is that most metals are malleable, ductile, and conductors of electricity and heat. Malleability is the ability of a metal to bend into other substances. Ductility, on the other hand, is the ability of a metal to form thin sheets such as wires. As previously mentioned, metals are also very good conductors of both heat and electricity. These attributes generally apply to all metals. Metal reactivity is a term that refers to how likely or how vigorously a metal reacts with another substance. Some metals like rubidium and cesium are extremely sensitive to reactions. The trend of metal reactivity in the periodic table is that it decreases as you go from left to right on each row. For example, magnesium has a lower metal reactivity than sodium. This trend happens because elements that are more to the right on the periodic table have more electrons. In order for their shells to become more stable, they would have to give up more electrons. The ionization energy is higher for elements from left to right, showing a direct correlation to reactivity. The other trend is that as you go down a column on the table, the reactivity increases. For example, potassium has a higher reactivity than sodium. The reason for this is a correlation with the atomic radius. As you go down a column, the radius increases, and as a result, the attraction between an atom's nucleus and its valence electrons gets weaker. This makes the electrons easier to pull away in a reaction, resulting in higher chances of reactivity. Because of this, they only require a minuscule amount of energy to trigger a reaction. Most metals react with halogens and form ionic compounds. The ionic compounds have the formula Mx, with M being the metal and X being the halogen. Some common examples of these elements are sodium chloride and potassium iodide.
Okay, Tickle. Drop the rubidium in the water.
Stand back, everybody, this one's going to be bad.
2 grams of rubidium will only react when our specially designed vial dissolves in the water, which gives John a few crucial seconds to get into our safety zone.
I like it already. Now, what's that going to do when it hits the water?
Imagine a depth charge in a bathtub.
Fair enough, mate. I'll leave it to it. Good luck.
Thank you.
Okay, John, go for it.
Warning, 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 extreme danger, clear the area.
As our cesium sinks in the water, the rapid generation of hydrogen gas should produce quite an explosion. And it does.
Magnificent. And I think that concludes today's experiment. There is, I should say, one more, even more reactive metal, francium. But for some reason, they wouldn't let us have any of that. Still, there you go. Today's lesson.
Never mixed alkali metals with water.